Hey guys, how's it going? I think this should work, hopefully. Let's see, it should be like getting started soon. We will see how this goes. That link should work, it's just that I haven't started yet. Let me see, maybe I have to like... Okay, I guess it'd be this. Okay, that would be the preview link then. I guess, I don't know what to send then. Let me update this. Since I think I screwed up the link here too. Okay, it should be on my YouTube page now, I think. If you go to this and then okay. That should work. This is a great start to the stream. We haven't even like done anything yet. Okay. How's it going, guys? I'm gonna pull up the chat on my phone because that's my OP setup. So today we're doing the cook-off. Yeah, we're doing the cook-off because that was what the vote said. Kind of scared me because getting echo. Sorry about that. So begin with the always awkward intro to the stream because why not? And yeah, okay. So I'm gonna load this. And basically the plan today is just to like go through the problems and do what I can do, and that's basically it. Should be just a chill time. So that is the plan. Shall we begin? Let me pull up all my stuff. Templates, the other thing. This is the simplicity of my setup. All you have to do is like do a few things. Okay, and I think all the links should be... Oh, I messed up the... Okay. Whoops. Okay. I don't like how it always like saves the stuff here, which is kind of annoying. I'll just figure stuff out. Yeah, the title's wrong. That's a mistake. Let me just fix the rest of the stuff. And just change the thumbnail too, I guess. Okay, what do I do here? Need like an image of this. And then once we do that, I'll start with div 2, I guess. Need just an image of this. And then we'll save that, I guess. This is generally stuff I should set up before stream, but I kind of forgot about this. So, one second. This is quality editing right here, right? How did I do this before? It was like this, and then I set that up to be like that. And then you gotta like, it's like a meta stream, setting up the stream on stream. Okay, that's good. Alright, thumbnail set up. We're good. We can actually start solving now. So, yeah, I'm gonna keep using Paint because that's like the only thing I know how to use. Okay. Perfect. Okay, let's just start. I'm gonna open all of these and then we're gonna do stuff. What are the div1 ones? Okay. So this is bowling strategy. In a cricket game, an over is a set of 6 valid deliveries of balls performed by one player, the bowler for this over. Consider a cricket game with a series of n overs, numbered 1 through n, played by k players, numbered 1 through k. Each player may be the bowler for at most L overs in total. Okay, there's no point in reading stuff out loud, I can't even understand it. But the same player may not be the bowler for any 2 consecutive overs. By the way, this is working, right? You can hear me? I would hope that you can hear me. That would be nice. Assign exactly 1 bowler to each over and away. NKL 10,000. So there's some stuff going on here. I think the way to do this is to just like, you can just kind of take the biggest one every time, or the biggest one meaning the player who has the most amount of overs left, because the way that would work is that you like, it's better to, I did start off with, hey guys, it's better to kind of like have a more even set. Whoa, why is this so small? It's better to kind of have a more even set of, like, say you have 3, 3, 3. This is going to be strictly better than like 1, 3, 5, because here at this point, you can kind of like alternate these, and then you'll have a very easy strategy of just winning. You can do, for example, 1, 2, 3, 1, 2, 3, 1, 2, 3, etc. But over here, you can't do anything. I'm doing bowlers right now, just starting from the easiest ones and then going on to it later. So, but here, for example, if you put 3 first, which you would want to do, and then you put 2 first, then you can only do that 3 times, and then you have to put 3 again, because if you put 1, then you would have to put 3 twice in a row, and that wouldn't work. So you would do it like this, and that would work. But if you had like 6 of these, then no matter what you do, you can't have more, because you can't put another 3 down. So basically what we want is we want to make them as even as possible, or as close to each other as possible, and the best way to do that is always taking the biggest one every time, or the biggest possible one. So I think the easiest way to simulate that is with a priority queue. Let's just do that. NKL. Oh wait, L is constant. Oh, what am I saying? Okay, never mind. L is constant. They're already all the same. In that case, okay, this is simpler than I thought. Then, I thought each player had a different number of overs that they could do. That's OP. So we basically have So we can just do something alternating like this. And then because it'll like use all of the overs without having the maximum amount of like turns played. It's just, and it won't have any two adjacent ones because everything's going to be different. It's just going to work. But if k equals 1, then like we can only have one turn. And yeah, it's basically not going to work if k equals 1. Why did I not do IOI? Because I'm bad. That's why. Wait, I already have L defined. Okay, so if k equals 1 and n is greater than 1, so there are two conditions. If we have k equals 1 and n is greater than 1, then automatically we can't do anything because we only have one player, so we can't have more than 2 in a row. And there's also something else in play here that the total number of overs we can ever have is k times L. So if k times L is less than n, then we also lose because that's just kind of, we don't have enough turns we can make. Yeah, so those are the two conditions. Or k times L is less than n, then it's impossible. Otherwise, we know we have enough ni++, so we can just print an alternating sequence, like I mod k plus 1. And that will just make the sequence we want. No, I'm not using a paretic here. I misread it, okay? It's fine. It's not that complicated. I just misread it. It's okay. What? Screwed that up a bit. Screwed up the input. What? How are you saying I'm better than William Lin? I literally can't even read inputs. I actually can't read inputs. I don't even know what's going on right now. What is going on? N space separated integers. Played by k players. What? Why? What is happening? Right now, my plan is just to start from the easiest and then move into the harder ones later on. That's basically the plan. Oh, what's my peak? Nice. Yeah, I'm starting with div 2. Okay, I'm so confused. What is going on right now? Two, 4, 3, 2, 5, 4, 1. Wait, did I never comment this out? Oh my god, okay. I thought I commented that out. I thought I was reading test cases. Okay, that's my bad. That's dumb. Whoops. By the way, if we get a wrong answer or anything, it's not that big a deal because we're not actually doing the contest. So this is 1, 2, 3, 1. It can be 1, 3, 2, 2, whatever, and then -1. And 1, 5, 1. By the way, yes, please don't spoil. That's not good. I'm trying to solve these on my own. Okay, let's, I've already screwed up this code like many times, so let's just make sure we didn't have any bugs in this 10-line program. No sarcasm at all. So read the input, check the cases, then print the sequence. And we have a compilation error. Oh, right, because I still haven't changed my template. Copy it. Yeah, CodeChef does not have the ActCoder library, sadly. So, yeah, you seem behind. That was a while ago. Okay, we got AC. Cool. That took longer to judge. The compilation error took longer to judge than the actual program, which is kind of confusing. Okay, anyway, that is the first problem. So there are n light bulbs in a row, numbered 1 through n from left to right. Each bulb can be in one of the states, on or off. All the bulbs are initially off. Adjacent bulbs, okay, graph, fine. Should reach a state described by a given binary string, okay. Cut up to k of the n-1 wires. Switch on some bulbs. Disconnect some bulbs from the electrical network. Each bulb is also connected to its at most. Oh, it's not even a tree, it's just a line. So you're given a line of bulbs. This is my interpretation. If I'm misreading, don't tell me. I want to like make this mistake by myself. I use Notepad++ because I want to prove a point that it doesn't matter which IDE you use. And actually, for the longest time, I used this site called Replit. And that was fun because Replit is quite possibly the worst IDE you can imagine. What happens is every time you like periodically it crashes on you. So sometimes it will just, for a full like minute, it will just log you out or something, and you have to actually. It's just terrible. It blocks you from doing anything for a full minute, and sometimes it doesn't change your code. So when you save, it doesn't actually save, so you don't know if you're running the right code or not. This happens multiple times. There's just a lot of terrible things that are wrong with it. Like there's no space in the IDE. Like you see how much space I have here? It's just all condensed. And even if you want more space, you have to like deal with not having a console then. The console's slow too. It's bash and you can't actually run any special commands. It's just terrible. But I stuck with Replit until I got to red. And that's why I'm using Notepad++ right now, because I'm making a point that it doesn't matter what IDE you use. It's just about your skill. You don't have to optimize these small things. Okay, anyway, yeah. Back to the problem. Good idea. Very good idea. So, you have n light bulbs. Should reach a state, binary string. Okay. So, initially everything's off. And you want some, like, components about some stuff that's going on. Like, yeah, I do like going off on tangents. Well, I have to make that point, and then I have to be clear I'm making that point, because otherwise then, like, nobody understands why I'm doing it. So I make that point, and then I try and just, like, make the point, you know? I mean, it's an okay question. I'm just, I'm just saying it really doesn't matter. And even you can make the same argument for saying it doesn't matter the language you use. That's a bit harder to say because languages like Python sometimes actually prevent you from solving problems, or they make it very, very hard to, but IDE definitely is not important. So we want to like cut some of these wires, and let's think about like the terminal states, I guess. So we have like 0, 1, 1, 0, 1, 0, 0, 1, 0, 1. And we want to, what do we want to do? We want to like break these into components. And then of these components, we're going to turn everything on, and then that's kind of weird. So of these components, the cost is either 0 if you have all zeros, or the number of zeros if you have at least 1, 1. Or if you have more than 0 of 1. I mean, yeah, Python is probably feasible. You can optimize it a lot, and you can make it work. But for beginners, it's very hard to do that. So I don't recommend using Python as a beginner, honestly, because there are a lot of issues with it. Like, for example, string concatenation is O of n, and that trips a lot of people up because they don't know it. So it's not beginner friendly because, in terms of CP, because there are a lot of things you have to know. It's easy to use, but it's not easy to use in a way that's like that can keep up with the other languages, basically. Okay, I'm gonna read the input since I don't know what else to do. There's gotta be some like simple thing here, but okay. So let's think about like what happens when we make components. So initially, stop doing that. Why? Okay. Yeah, I'm gonna just spamming is bad. Don't do that. So if you do that again, I'm just going to prevent you from chatting because there's no reason to spam, honestly. I don't know why you would do that. So let's get back to the problem. So initially, it's fine, Aaron. I took care of it for the time being. If he does it again, just like, I don't know, ban him or something. That's not very nice to do that. So like over the whole array, you already have the cost of like everything. Yeah, Aaron, it's all your fault. I hate you forever. Of the whole array, you already have the cost of everything. So if you break stuff into a component where there is at least one 1, then like there's no point in using the component because you already have this cost when you have the whole array. So the only components you want to make are ones that have zeros in them. That would be a first observation. See, the annoying part is the edges because that just makes it, yeah, spamming is not pog. You can use Twitch speak if you want. The annoying part is the edges, because edges have I just have like, they cost 1 disconnection. Which is weird. So let's see. Let's just first check if we have all zeros. So if we have all zeros, we automatically win. And then if we have, otherwise we have at least 1. So yeah, okay, look, saying messages like Binod is, I mean, it's meaningless, but I guess it's fine. But if you're gonna spam it like 20 times, that's just stupid. Yeah, search up Binod. The video that made it is actually kind of funny, so I would recommend watching it. There's some like smooth way to implement this, but I don't see it. Yeah, sorry, I don't know how to pronounce things. Blame my accent. It's just like annoying. Yeah, I know. I'm trying to actually figure out how to implement this because this is not like friendly. I'm not being distracted. I'm just genuinely like confused about this. I guess we can just fix the ends. We could just say like, okay, let's just do this. We'll do some sort of like 2 pointers thing. My age, 17. If what? If AI is equal to 1. Cur equals I plus 1. And that, basically I'm doing a 2-pointer approach to extract all ranges of zeros. And so if we're at this 1, then we assume the next 0 is going to be over here. But then if we have another 1 over here, then we can just basically assume the next 0 is over here until we hit something that's actually 0. And then once we hit a 1, we can just like make the range happen. So if cur is less than I, then cur minus I plus 1. No, if cur is less than I, then cur minus I, excluding this, so we don't want to have plus 1. If cur is equal to 0, then first equals would it be cur else. Okay, and then we can do something like last equals n minus cur, and that works because like if we have a 0 at the end, then once we get to the 0, the cur pointer is going to be here, and n is going to be here, so we get exactly 1, which is what we want. So sort ranges dot r begin ranges dot. Okay. We can assume that each range of 0 is going to take exactly 2 like destructions to count, except for the ends, which means that we just kind of like do stuff. Should be long. Okay, so this is basically what I'm doing to handle taking the first and last, since each of them only takes 1 turn, so it's kind of like weird. Basically, we just fix everything that we take. So let's while wait, for L equals 0 as less than ranges dot size. If turns is less than or equal to 0, 1, return break turns minus equal to 2, then r plus equals ranges I. These are in reverse sorted order, so this should work, I hope. Okay. What? I can't. Oh. Any other compilation errors? Going for what am I gonna do as president? Doesn't even make sense. I would just sit at my computer and be useless. That doesn't work. That's cool. Doesn't even print anything. What is it doing? What is it expecting as input? Oh wait, what am I reading in an array? We have the string. Okay. 2. Nice. And the reason being is that I'm maximizing the count. So what I'm doing is maximizing the amount that we lose. But what I actually want to do is maximize the amount. Yeah, well, I want to maximize the amount that we lose. We have to subtract it from the number of zeros we have. Okay, let's make a few more tests. And just one more, just like not be annoying. 0, 1. Answer for this should be 1, 1, and also 1. Okay, let's try it. Whatever, don't really care about wrong answers. Hey guys. Yeah. We do have a wrong answer. Nice. Okay, what's with that? So this is why you don't rush things, because you want to make sure everything's right. Guess we can make a more complex case. 8, 4. That should be 0. Okay, wait. 1. We're resetting the state every time, right? Yeah, that shouldn't matter. The fact that we have test cases doesn't matter. Zero. Okay, so we'll stick on another 0 here. 1, yeah. Now if we put this here, it should be 0 again. Oh, that's a problem. Okay, what's with that then? Wait, why does IDE mode matter? Does it make a difference? It's just pasting text. Oh, what? Oh wait, this should be I. Whoops. How did I pass this sample then? Because that should have gotten first wrong and therefore done everything wrong. Oh wait, no, it doesn't even use the first one. Okay, that's a fix. Wait, what's wrong with the UI right now? Like, all you need for a contest is just text, maybe math text, what they have, and a submission place. And they have both of those. Okay, still wrong answer. Well, this is annoying. Do I just need, like, bigger cases? So that should be 2. Should also be 2. That should not, oh wait. That should be 3. If we make like all of these bigger by 1, it should be 4. That should be 17. Okay, that's annoying. So what's with this? Are we... That's right? Like we print all zeros if we... Yeah. So we don't have any 1s. Automatically we don't have to do anything. Automatically we don't have to do anything. What is happening here? Three, 3, 4, 3. The answer should be 3 because we can do that. So I equals 0. We don't have any turns left, then we just like lose because we can't do anything. If we just merge these. It should be 0. Yeah. Yeah, I can do it. I'm just choosing not to for some reason. Of course. What if we just don't have any ranges? Does that cause a runtime error or something? I mean, it shouldn't. It should just be an empty vector. Yeah. What if we have all ones? Then C0 is 0. So that's totally fine. I am breaking on B. It's happening live right now. If a bulb was switched on before this step and it was not disconnected in this step, it remains switched on afterwards. What is happening? What I'm imagining is that I misread this somehow and then I'm going to have to redo this whole thing. That'd be nice. 0. If the value is 1, if cur is less than I, then if cur equals 0, first equals I. Otherwise, first is nothing because you don't have a first. Did we screw this up somehow? What if we just don't have a first? Oh, I see it. Okay. Whoops. Sometimes we can't even, like, undo the first or the second. Yeah, that makes sense. Like, if k is 0 and if k is 0, I make the assumption that we can just do this, but sometimes we can't. Okay, I think that should fix it. Oh, wait, shoot. I did not mean to run it. What did I get on map R? I'm pretty sure it's bad, so I don't want to say anything. Okay, this should work. Finally, Jesus. That was stupid. Alright, we're on we're on C. Finally. God. Okay, you're given a sequence. Select a subsequence and reverse it. Resulting sequence, you want to calculate the maximum sum of a contiguous subsequence. What's the bounds? 10 to the 5th. Okay. A contiguous subsequence is subarray. Possibly an empty sequence of sum 0. Find its maximum possible value and a subsequence you should select in order to obtain this maximum value. If there are multiple solutions, you may find any one of them. Try to solve this without compiling. How would I solve it without compiling? Try to solve it without reading? How does that even work? You're like trolls, aren't you? What are you saying? So take a subsequence and reverse it. I guess we're expected to have O of n. What's the time limit? 1 second? Okay. So Okay, with these types of problems, the typical thing we have to do is to try and fix something, like fix the left endpoint and see what happens. So let's take the sample -4, 2, -4, 3, -5, right? Now let's say we're going to take a subarray that starts here. What can we do in this case? Well, we can you can reverse any subsequence though. You can reverse any not necessarily contiguous one, and then you have to take a contiguous one. So that's typically called a subarray, but they make it like really weird, and they call both of them subsequences for some reason. I'm not really sure why. All right, so here we want as many positive elements as possible. Now, if we have a certain length, this would be relatively simple, I guess. What we want to do is swap out like all of the kind of negative elements with positive ones. I think negative elements is weird. Okay, does fixing the first element help? Not sure if it does. We might also be able to like reach behind, and then, for example, if we have like 50 back here, then we'll want to like swap these two. So there's some subarray that we want. But we can't both reach behind and forward at the same time. Like if we're gonna do some stuff here. Yeah, I'm slightly bricking. I think I'm mentally tired from that test more than I expected to be. Like here, obviously we can just do that and be done. It doesn't matter if we take a middle element, so we can assume the subsequence is even, but that doesn't really matter. Or the length of the subsequence is even. And let's say we want to pair this number here with some outside number. It's like some subarray of the positive numbers, either ahead or behind. Can we just get all of the numbers? Like, Could we just bring all of the positive numbers into this range ahead of us? It might just be possible. Let's say, for example, we have this, like plus, minus, minus, plus, minus, plus, or something. And then we're going to take the number of positive elements we have, so it's just kind of this. And so we can swap these two with these two. And we kind of just bring all the positive numbers out. This is one example. Does it work for all of them? That's kind of more important of a question. I'm on the third problem right now. Stuff is taking a while. I'm not gonna lie, I'm kind of tilted right now. I don't know why, but I am. What's happening here? Yeah, I might not even get to E at this rate. So let's say we're gonna get all the positive numbers after this. Wait, can we just always get the positive numbers? I think we just straight up can. Well, they may be useless for you, but for other people, it's like they're still useful. Because not everyone's solved until E, you know. Okay, I'm pretty sure the way this works is because we can like swap all of this. Like let's say we're gonna take a subarray starting at the beginning. Then once we do this, we're going to want all of the positive elements to be in this prefix. So this prefix of length of the number of positive elements. So we'll call that CP for competitive programming. And either we have a negative or the positive's already in this sequence. So if we have a negative, then the corresponding positive is like somewhere else. And what that means is like that's a problem. We want it to be in this sequence. So then we just kind of like put them both in the sequence and we swap them. And then because all of these are going to be contiguous, everything in here is going to be swapped with everything in here, but in reverse. So all the positives are going to end up in this prefix, and all the negatives in this prefix are going to be like phased out. Okay, that should work. Well, I break down B too, so that's like not good. Oh wait, S plus equals AI. Plus CP. And so now what we do is we keep a pointer here, and then we're gonna maintain that this pointer is always on a positive number. And basically we'll use this pointer to we'll iterate through all the negatives here, and then once we find a negative, we'll use this pointer to find the match for the positive number. Yeah, that's fine. If AI is less than 0, less than or equal to 0. Yeah, we'll treat zeros as negative, because why not? Doesn't really matter where we put zeros. While a point is less than or equal to 0, plus this point. And if AI is less than or equal to 0, neg dot push back I plus 1, and we can put the pointer at pause dot push back point. And we have to increment the pointer because we can't use that number again. And that's cool. And I should also print the sum. Five, 1, 3. Oh wait, it should be plus 1. 5, 1, 4. Swap that, and then 0 and oh wait. Yeah, that's a thing. Okay, we'll just do that. Imagine we're definitely not getting the div 1 problems. We'll see if we can get more of these. Some new insertions. You're given a circular sequence. Element A1 falls after AN. Okay, we got C. You may insert any positive integers at any positions you choose in the sequence. Let's denote the resulting sequence by B. This sequence is also circular. Okay, so it's like a weird, like you have a circle, and then you're going to take some subset of points on that circle. And then I think the B of S to F is like, if S is here and F is here, then you'll just take the subarray that like goes around there. That's, I guess, what it is. So for each K, find the smallest possible number of elements that need to be inserted into A. Form a sequence B. Oh boy, GCDs. Form a sequence B where there's no subsequence B of P and Q, such that the size is at least K, and there's no pair of consecutive elements with GCD 1. That's not weird at all. What's with that? So we can kind of like stick some primes in, and that's going to work fine. Yeah, we're 3 away from 1.6K. Come on, guys, we can do it. Subscribe now. It's going to work. If you haven't done it yet, do it. It's like literally a single click of a button, and you can undo it at any time. Doesn't really matter. I believe in us. How people have solved this? This seems like I might be misinterpreting this, but this doesn't seem as bad as the other ones were. I don't really know why. At 1 million. If I ever hit 1 mil, I will definitely just do some sort of insane special. I don't know. Something cool. Alt reveal at 3 mil. You guys know my alts. You know my ActCoder alt at least. Okay, so let's think of the elements like this. We're going to draw a circle. That's what the sample is, right? 5, 6, or 3, 6, 4, 5, 9. So B is a sub. Oh wait, never mind. Okay, so B is just what you get after insertions. Conta is not my alt. Conta ors is my alt. Real account is why did it take me 15 minutes to solve B if my real account is tourist? Okay, so let's think about the GCDs. GCD here is 3, GCD here is 2, GCD here is 1, GCD here is 1, 3. I'm not tourist. I just said that. What are you talking about? Do you guys actually want to see us speedrun? I could do that if you want, but that wouldn't be like... I don't know, that would just seem weird. Yeah, I'm pretty sure I already have... I'm not looking at the tags. I wish I could disable... Is there a way to disable the tags? I don't want to see them. Okay, so here's how this is gonna work. This actually seems easier than the other problems, which I'm kind of... I can't disable tags, that's sad. I'm not tourist. What were you orsing me about then? There's no other reason to ors me. I should read this chat. Childhood reveal at 2 million. My childhood is like boring. Okay, here's the idea I am having. So a circular subarray of size k is the same as taking k minus 1 of these like gaps. And k minus 1 of these gaps. And each of these gaps must have GCD greater than 1 for the subsequence to hold. So inserting an element, like we can insert some massive prime, like 10 to the 9th plus 7. And we can insert a different massive prime at each point. Now I'm on D. So once we insert a massive prime, like for example here, it's going to like kill this number. It's going to make two things where both GCDs are 1. So right now we have this, but yeah, we can insert 1 too. Whatever, it doesn't matter. We can insert just anything that makes the GCD 1. So right now we have this grouping of size 3, and then we can't take any other like ranges. So to make it so we can't have any grouping of size 1, for example, k equals 2, we only want to take, we won't be able to take any one of these. Not code forces, because it's not very relevant to code forces. I did post it on Discuss though. This just told me to put. Oh, never mind. So let's say we have k equals 3, and we want to like break these into only size 2 things. Then we can put it here, and then we'll be done because everything else is a size 1. So in general, if we have a run of length r, and we have to split it so no grouping is a size at least k, then this is kind of almost the exact same code as B, actually. That's kind of interesting. If we have a thing of length r and we have length, and we want to break it into things of length k, there's some like sequence of stuff we can do. Is it ceiling or floor? That's what I'm thinking right now. Is it ceiling r over k or floor r over k? This is what I'm thinking right now. So the way, let's say you have like, for example, 7 gaps, and you want to break it so you have nothing more than size 3. And you can do that here, and you'll be done. Let's say you want to break it so you have nothing more than size 2. So you do it here, and then you kind of like resolve that, and then you break it here, and then you resolve that. So I guess it'd be it would be floor, because it's the number of groupings. It's the highest integer you have, such that it's the highest integer x such that kx is less than or equal to r. Because if you can stick on one more x, then you would have more groups to break, but otherwise you don't. So that would be the floor of r over k plus 1. So basically over all groups, it's just the sum of r over big K, where k is the original parameter, and the floor of that. So that's cool. And let's see, can we harmonic series this? I think we can, right? Oh wait, it's not even harmonic series. We can literally just go through every like if we break this into the subarrays that we have, we can just go through every subarray. And that works because every subarray will contribute every subarray of length r will end up contributing exactly r units of complexity, and the sum of r is O of n, so that's fine. Okay, so let's figure out a smooth way to implement this. GCD of so this is we can actually reuse the code from problem B, I'm pretty sure. And it's at least 2, perfect. What? What do you mean? Why? Take me to the practice problem then. I guess this is my code. Yeah, it is. So, you just do this, and then oh wait, this should be first plus last, and then okay. So for LOK equals I know how to go to practice section. I just don't want to. K plus plus LO ants equals 0. Now for LOX ranges, if x is less than k, then automatically it contributes 0, so we don't have to do anything. So we can break. And everything after it is going to contribute 0 because we're sorting them in reverse order. Otherwise, ants plus equals x over k. Come on. Let me copy this. Nice. What's with that? Two, 0. Why is it 2? Wait, this should be right. Oh wait, it should be x plus 1. X plus 1, right? No, sorry, that feels so wrong. What am I doing here? It's still k minus 1. So we take this. Something's messed up here. So we don't want to be able to take any contiguous k minus 1 of these. Because we can like start with this one and then we can just like take all of those. So I want to eliminate all of this somehow. Everything's right except that one. Everything's right except the formula. So we have R of these numbers. And I think it's x over k minus 1. That fits that, but is it actually right? Okay, so we basically want to make it so we have no k minus, well, this is the same notes. So we have no k minus 1 of these numbers. So that's like fine. And it means that oh, this is k minus 1, not k. What am I thinking? So it's the floor of R over k minus 1. Yeah, that makes sense. Because for every group of k minus 1, we have to break it, and we might as well break it by putting something at the end, so it's like it's still floor. Guess we can try and read this. Wrong answer. Okay. What's with this? Let's rotate this array, I guess. What we can do is kind of like make it so this stuff is in the center. So for example, 5, 9, 3, 6, 4, and then it's not on the end, it'll be somewhere else. So this should still be the same exact answer. And I forgot the multitests. Oh, I forgot to print a new line. Is that a problem? I'm not sure if that's a problem. Because it might be. I don't know though, because it shouldn't, technically it shouldn't matter. But maybe it does? I don't know. Okay, it's still wrong answer. Oh wait, this should be if x is less than k. Yeah, that's dumb. Otherwise we might like divide by, wait, that's only a time effect. Because that makes it so we consider strictly more ranges, right? Let's do something dumb. 2, 1, 3. 3110, 3110. Okay. So 2, 3, 3. See ya, Aaron. 2, 3, 3. So to make it so we can't take any two elements, we have to insert elements at both positions. Okay. Here, if the whole thing is connected, I guess it becomes a problem. So if ranges 0 is equal to n, if range of 0 is n, what does that make it? Because in my example here we have this to this and to this. So we have 3, 3, and 3. And then all these GCDs are 3. So we have to make it so we can't take any 3 elements. And here we have to cut it twice. So it's kind of like you still have this, except the first cut you make doesn't actually do anything. So I guess that'll be it. That kind of messes with things though. That wouldn't fix everything. Because now we're gonna have like 4 here. We do need 2 cuts here, but this is stupid. This is gonna work. This should not work, but it might. Let's do 5. So it'll be 5. This is problem D. Probably the last one I'm gonna get to. So now we have 5 of these, and we have more. So we have 5. We have a circle of 5. If we want to cut it so can't take any 2 elements, we have to cut everywhere. If we want to cut it so we can't take any 3 elements, for example, say we cut here, then we have to also cut here and here. So that should be 3. If we want it so we can't take any 4 elements, we can just cut it anywhere. If we want to take it so we can't take any 5, we also need to do 2 cuts. Yeah, okay. That seems right, although I'm still not sure. It's just the edge case of having everything have GCD greater than 1, which is a problem. It's still not going to work, actually. Why? Come on, man. Like, just because the mod's gone doesn't mean I'm still not here. Does that make it so the message still exists? Okay. I guess that's fine. I mean, I don't know why you would get timed out, then immediately, like, go back to doing it once you... I don't know. Okay, I guess we'll finish off with this problem. So, we have a special case here. If everything has the same GCD, what would happen then? But if range of 0 is n, that should be right then. Because we have to like add an extra one. It's not the statement this time. I'm just breaking again. I'm throwing. I forgot to update the sub count. I should do that. We got the 1600. Hooray! So we'll do that. So maybe we're at 1.6k now. Nice, we got it. Alright, let's just finish this off. If we can, even. This time the problem statement's fine. This is my fault. I'm messing something up. 8. Let's see if this is alright. Should be 8, and then 5 because we need to do... I guess it'd be, think that should fix it. Because, okay, the first cut we do, I was kind of wrong. The first cut we do does remove a value. But now we have to solve the array of, like, r minus 1. Because the circle is, like, a thing. 8533222. Let's try that again. I should change it, right? 843222. Okay, that sounds more right. Because, for example, for 8, we have 8, like, we have in a circle. If we cut, like, all 4 of these, then we don't have any gap of size 2. That's still wrong. What am I doing here, then? What am I doing here? X is less than K. I'm gonna just keep trying things at this point. The goal is just to solve this problem before the stream, honestly. So I think, okay, this was wrong also because we wanted to, like, this value could still be 1 even if X is less than K. Okay, finally. Jesus. Okay, I'm gonna use my last, we're definitely not even gonna be able to start this problem. So I'm gonna use my last 5 minutes to just explain what the hell just happened. So basically we have this circular array. Let's use the sample. And what is min seek? Is that this? I guess it will be this. So we have 3, 6, 4, 5, 9. We're given a circle. Come on. Given a circle like this, where each point on the circle has a number. And we're given some parameter k, where all k, we're basically, we have to insert some numbers. So for example, we'll put this new number here, and we'll make it like 12 or something. Although that's a bad choice of a number. What you want to do is insert some numbers such that there is no subarray, no circular subarray, that is no like arc on this circle, such that it contains at least k numbers, and the GCD of all consecutive elements is greater than 1. So these properties are what we don't want to have in any subsequence, or any value of k. So for example, this GCD is 3, this GCD is 2. So if k is 3, then this violates, then this is a valid sequence for this, so we don't want that to happen. So the way we do this is basically, all subarrays are, so when we insert an element, we can just literally make it 1, and then no matter what we do, both of these GCDs are going to become 1. So it kind of breaks this like contiguous range into 2 separate pieces. And so what we want to do is we want to, instead of having a subarray of length k, we can kind of think of it instead like this, where if we think about it like the gaps in between all of the points on the array, we want to make it so we don't have any contiguous series of gaps. How do I make this bigger? Can I seriously not do bigger than that? Just want to get rid of this. Come on. This pro god tier paint skills right here. Okay, so instead of making it so we don't want k numbers, we can make it so we don't want k minus 1 gaps, where all of the gaps have GCD greater than 1. So now we're operating on this new array, and this new array is also circular. So for example, we have something like this. Let's say 3, 2, 1, 1, 3. And now all we need to do is we need to make it so what we can do is in an operation we can remove an element. We can just straight up remove an element, because inserting 1 here is equivalent to just getting rid of this. So in one way we can remove an element, or we can mark it as invalid. When we remove it, we don't remove the whole thing and then merge these two. That would be bad. We don't do that. Instead, we just like mark it as 1 or something. And then we want to make it so we don't have any circular subarray of length greater than or equal to k minus 1, where all numbers are greater than 1. And again, in one operation, we can set a single number to 1. That's the reduction of the problem. So the solution is basically, I have a minute left, so I have to like rush through this. Basically, any like sequence broken up by 1s is independent of each other. So for example, if this was the array, then these two would be independent. And we need to independently make both of these equal to, we want to independently make both of these like satisfy the property. So let's say we have 3 spots and we want to make it so there's no subarray of length 2. Basically, for every group of 2, we cross out the last element. And then that will make it so everything is at most k minus 2, which is what we want. And so the formula for the number of things we need to do is it's the length over k minus 1, the floor of that. And we just kind of do that over all the subarrays, and you need to write some code to like break the stuff up into subarrays. And we can actually iterate through all the subarrays, because a subarray of length L will contribute exactly L units of complexity to the array, provided that we ignore all subarrays that are of size less than the current value of k, or k minus 1, because those subarrays will automatically contribute 0 in the floor value. And one final thing, if the entire array is greater than 1, so for example we have this, where everything is like 3, then this is a special case and has to be handled separately. Basically, no matter what you do, your first removal will make it so you have 1, and then now you're solving a problem of length n minus 1, and it's basically just that, where f of n minus 1 is the cost of solving for n minus 1. Okay, yeah, that's it. That's D. I'm sorry I didn't get the E. Kind of bricked on all of the, like, A, like, B, C, and D. That was sad. But I eventually got stuff. Okay, that's it. It is 1. I gotta end the stream here. See you guys. I'll end it like this. And then end stream.